All right, welcome. How's everyone doing today? Good. All right, so welcome to the session, Sizing the Mixed Reality Revolution, the past, present, and future mixed reality partner perspective. Long title, I know, but I hope this session won't be too long for you and you get some valuable time out of the next 45 minutes. What we're going to talk about is the past and the present, so I will show you some of the applications we have developed and tell you the lessons we learned from those, and hopefully you can apply some of that to your own applications. Then we will quickly move into the future, which is, of course, mixed reality and artificial intelligence. And I'm going to show you a demo, and you will also get the source code of the demo, which is using Windows machine learning running on the HoloLens with the April 2018 update for near real-time object recognition. And then at the end, we spend a good chunk of the time, like 20 minutes, on my top 10 HoloLens development recommendations 2018. And there will be lots of good best practices there at the end. So there won't be any intro to HoloLens development or Unity development or anything like that. If you're very new to the topic, there were some good sessions here built. You can follow the recording. I also did some talks at other conferences like Unite, which are up on YouTube. And at the end of the deck, I will have a slide with all the links I mentioned throughout the talk so you can get a snapshot of that. My name is Rene. I'm Director of Global Innovation at Hologram. I also run the Immersive Experiences team there. So I don't work for Microsoft. We are a mixed reality partner and have been developing for the HoloLens since 2015. And I'm also a Windows Development MVP and Regional Director. And I've been doing computer graphics and also deep learning since maybe around 15 years or so. All right, so let's get started. Quick video about the company I work for, Hologram. We're headquartered in Kansas City, but we have offices all across the globe. I'm from Germany. And we don't just do immersive, we also do cloud computing and digital transformation. So we think about the whole digital transformation holistically from the back end to the front end. Front end could be an app, could be a 3D, it could be a HoloLens app, whatever, right? This video is less than a minute, shows you some of my team members, and shows you, most importantly, also some of the HoloLens applications we have developed. And let's take a look. Okay, enough of the marketing, huh? Let's get started. Past and the present. So we started in 2015. We all saw the announcement, or probably most of you saw the announcement at Build 2015 with the HoloLens. We were all excited. A couple of us got the opportunity to actually try it out in the Holographic Academy. And so that was cool, but we didn't have the device available. So we used some other devices like the Gear VR or the Google Cardboard. And especially the Cardboard, you can just insert your phone and you have the cutout for the camera. So we could actually run some AR frameworks on top, like Warrior. So we could already experiment with the user experience and could try out some things, but also make ourselves familiar with the Unity development environment, because this is what is mainly being used for mixed reality. Yeah, later on, we got invited to the HoloLens Agency program, which is now the Mixed Reality Partner program. And we got access to the HoloLens emulator and the SDK. So we got the origami running in the emulator, which probably a lot of you have done as well. And later on, we also got some of our apps running. Then we got the devices, and we got the origami running in the real world. So we were all excited about it. And that is the team as it is currently. We're at 8 plus 2 people, so not everyone is on the photo here. But yeah, back then it was just like 2 people or so we've grown the team quite a bit. Very specialized skill set. So for example, we have a 3D artist who does 3D optimization, or actually also can create 3D models from scratch. We have a 3D animator, and she can take those 3D models and bring them to life with really amazing animations. And we have a UX lead, for example, who also takes care of the vision and makes sure the user experience and the UI is well designed and works well. We also have Unity developers, of course, which are really specialized in Unity and computer graphics development. And then we have more of a generic C++, C# developer that typically take care of the backend integration and lower level things which we then can show up in Unity as libraries. If you don't have the luxury of having such a team, I will give you some recommendations at the end how you can leverage the tribal knowledge out there and get going even as an indie developer, right? So what are the lessons learned? And I just picked 3 applications here for that because most of the stuff we do is under NDA, and also I wanted to have something that fits for the rest of the session here. So one app we did last year for Build was the Tire Explorer application, and we showed that actually at the expo there. So you have probably seen some apps there this week. They have these aquariums, so we had Tire Explorer running there as well. And, well, pretty exciting, and a couple of lessons learned here. So what we're first of all using is so-called Vivoria model targets. Actually, let me roll the video here real quick. So what you can see there, first of all, this is HoloBeam. I'm going to talk about HoloBeam in a couple of slides. But now look at the guy, his name is Justin. He's looking at this real-world tire, right? And that real physical tire is being recognized. So what we're using here is, again, Vivoria model targets. And what you can do with that is you can take an existing CAD model of a real-world object and use that for tracking. So there's no marker, there's no traditional marker like QR code or anything on that real-world object. You can use the real-world object, you need to take a CAD model of that and optimize it. Optimization is important because it needs to fit into the rendering budget of the HoloLens, right? It needs to be around 100,000 polygons. Another lesson learned with using model targets, you need to experiment a bit what is part of your marker-based model. Because, for example, we only had the rim in there. We didn't have the rim in there. And then we later on added the rim to the 3D model. And of course, the tracking was much better because there were much more feature points to track. Another thing you can see there in the top, there is this light mounted. And this light gives us a better contrast on the outside of the tire. So there's a bit more contrast on the rubber part, and that tracked much better. So there's a bit of things to experiment, but model targets is really awesome. It's a great experience for the user. What you could also see are the rendering of those tire components. So we all use custom shaders there. If you're not familiar what a shader is, it's basically a little program that runs on a graphics card that defines how an object will look like. So how does it reflect light and so on. And all of those components here use custom shaders. So how did we develop those? We used Shader Forge, which is a graph-based shader editing tool. So you don't have to write all the shader code from scratch. You can actually use some tooling to put some nodes together. And that worked well, but at the end, we actually still optimized the code it automatically produced. Right? Those tools are pretty cool to get started, but if you want to get the latest piece of performance out of it, you still need to hand-tune it a bit. So that's my recommendation to you as well. By the way, Shader Forge was just open source and also released for free. Because the developer thinks that it's probably not worth it to invest anymore, because Unity 2018 ships their own graph-based shader editing tool. So you probably want to check that out if you're looking into shaders. Yeah, and then we have HoloBeam here. This is my colleague, Rod Shelton from Seattle. We call this version of him the HoloRod, and he's explaining about those tire components, right? And I'm going to tell you about HoloBeam in a second. This is another piece we did with an automotive client. And this application, I picked it because it's using machine learning. And you can see this person there wearing a HoloLens. So he looks at that component, takes a snapshot, and once that snapshot is taken, it is sent to a backend where we have a deep learning framework that was trained to recognize a certain object. So it will recognize that object and then pull in some extra info about it. And the awesome part about it is the user can just use their hands for the real-world tools, right? They're wearing a computer on their head with the HoloLens, with displays. We have automatic recognition of those objects, so they can use their hands for real-world tools. And that was a really amazing use case. Back then, we had to use a backend for the object recognition. Now we can do this on the device, which I'm going to show you in a couple of slides using Windows machine learning. And that is always a challenge if you go to those factories, right? Connectivity can be tricky, because there's a lot of communication already in the area. So now that we're able to run it on device is amazing. All right, another example, HoloBeam, our immersive telepresence solution, which we're working on. So what are we doing here? We're taking a 3D depth camera, like the Kinect or the Intel RealSense. We take the depth data plus the color data, encode that, and then stream it over the internet, just using normal internet connection, 3 to 5 Mbit, adaptive streaming, and then we can reconstruct it in real time as a point cloud on the HoloLens. So how are we doing that? By the way, let me play the video in the background so you can see some stuff while I talk about it. What we're using is WebRTC for the transmission, which stands for Web Real-Time Communication. It's an open standard. And there's also an open source implementation, mainly driven by Google, actually. What we did is we forked that, because we need to figure out how we can actually transmit the depth data, right? So what we're doing here, we changed how the video stream is being produced, and we take the depth data and encode it in a special format so that we don't have any compression artifacts when we decode it. Because if you apply just normal MPEG or video compression to a depth data stream, you will have lots of compression artifacts, and the finger might be behind you or something like that, because depth data is a bit different than just normal color data, right? So that's the secret here, basically. If you want to do something like that, look into WebRTC. That's really the way to go. So how are we achieving real-time rendering on the HoloLens of all of those points? We're using also a custom shader, all handwritten. It's a geometry shader, which gets fed into, so basically, we decode the video on the HoloLens using Windows Media Foundation. So it all happens on the GPU already, the video decoding. And the HoloLens supports H.264 as a video codec for hardware decoding on the device. So that's how you can actually pretty fast decode the video stream. Then we take that as a video texture and then feed that into the geometry shader, which is then emitting all those points. So if you want to render that amount of data in real time, there's no other way than using a custom shader. Cool. So here's another video, which we just did the other week. So we also have now collaboration features implemented. So as you can see, we can play holobeam chess. And you cannot see the other person, but now we also added the feature where we can collaborate on 3D models. So I can do things like that. And you see there's almost no latency. So this is in Germany and USA, and it's pretty awesome. Okay, let's talk about the future. So what is the future again? Mixed reality and AI, right? So let the man speak himself. We all know him. We all love him. Alex Kipman, technical fellow and the visionary behind HoloLens and the Kinect. And as you can see in this LinkedIn post, he pretty much made it clear. Also, Satya Nadella pretty much made it clear, right? This is the future, mixed reality, perception, and artificial intelligence. That's really what we're looking at. And, the awesome piece is we can do some of that already on the HoloLens these days. But first of all, what kind of AI are we actually talking about these days? And I don't want to spend too long on that, but I thought it made sense because it's often so confused, the whole terminology, right? So when we talk about AI, artificial intelligence, it's basically algorithms and techniques to simulate human intelligence, right? And a subset of AI is machine learning, right? And that can have other algorithms like support vector machines, random forest trees, and all of those fun things. And another subset of machine learning itself is deep learning. And deep learning leverages deep neural networks or artificial neural networks. And this is where all the progress is happening these days, right? Every other day, you see a new deep learning model that is doing amazing things we have not imagined a couple of years ago. And again, this is where all the progress is happening. So when it's being talked about AI, it's mainly about deep learning these days. So what is deep neural network? What is deep learning? Again, just in a nutshell, much better explanations. I will have some good links at the end where you can learn that stuff in deep. So artificial neural networks tries to simulate an animal brain. And the neurons in that case are connected with synapses, right? And for an artificial neural network, those neurons are basically computing functions, which can also be tuned with a couple of parameters. But all the data, all the training data is stored in the connections, in the synapses, if you will, right? These are connections. And it's basically floating point values. As you can see, if you have lots of those floating point values, you end up with a vector. And if you have lots of vectors, you get a matrix. And then you have basically a huge multidimensional matrix. And that's where all the training data is being stored. So how do you train the neural network? A bunch of different ways to do that. Most commonly these days is still supervised learning, although reinforcement learning is gaining quite a bit of traction. But for our use case, for the model I'm going to show you, it's supervised learning. So you take a training data set with also contains the desired output. You run it through a neural network, and then on the output side, you check the actual output with the desired one. And then you probably have an arrow, and that arrow is being back-propagated, right? And the backpropagation basically adjusts the weights. So it adjusts those values that are connected between the neurons. And this way, it can store all that information. And if it's trained well, at the end, it will generalize information and enters the so-called inference phase or evaluation phase. So you can give it data it has not seen before, and it will predict the correct output result. And you know what? The awesome piece about it is we can run inference on the device now with Windows 10 April 2018 update. There's a good session about WinML. Just in a nutshell, I call WinML the DirectX of AI. Because what it does is it abstracts away the hardware. So you don't have to worry too much about all those specifics of if your Onyx model runs on a GPU, CPU, or one of those neural, like, tensor processing unit, whatever it is, right? Whatever accelerator chip it runs on, you don't have to worry about it. It basically, you just have your abstraction layer, which you really care about. So you could take a model, train it in the cloud. You could use things like custom vision AI, which is really easy to use. You just upload a couple of images, label them, then you can hit a button to train it, and then you can export that as a so-called ONNX or Onyx model format. And then you can take that Onyx model format with the pre-trained data and deploy that as part of your application and run it in real time, or, well, almost real time, but you can run it on the device with WinML. And that's really awesome because things are getting, the puzzle pieces are fitting together because we can use best of both worlds there. Good, beefy machines in the cloud to train the data and very short latency on the device for on-device inference. Yep, and you probably have seen the announcement about the HPU vNext, the next version of the HoloLens, will further integrate AI with the new HPU. But we can already do some stuff on the HoloLens we have available these days. So let's finally get to the demo. Typically, I would now take my HoloLens and put it on and show you what I'm doing. But the thing is, for my object recognition demo, I'm using the camera. So I cannot live stream at the same time to my computer when I'm already in my app using the camera. What I'm instead going to show you is a video, how that works, and then we're diving into the code. I'm showing you the most important code snippets, and you will get all the source code there with the link on my GitHub page. All right, so let's take a look at the video here. So I recorded that at home. I took some of the plush toys
This is
from my
likely a
kids.
studio couch 2.5 meter in front of you.
So don't tell my kids that I took those plush toys when they were in school.
This is likely a teddy 73 centimeter in front of you.
So it recognizes the object. We use spatial mapping to measure the distance to the object, right? And then we have a speech output.
This might be a Sealyham Terrier 57 centimeter in front of you.
I'm using a SqueezeNet model here, which is trained
This
on
is
the
likely a
ImageNet
teddy
database.
77 centimeter in front of you.
And the ImageNet database is a, a very default database. It can recognize 1,000
This might be a
different
Lhasa
objects.
69 centimeter in front of you. This might be a West Highland White Terrier 70 centimeter in front of you.
And examples could be, of course, retail, right? Just think about you put on a device, you walk
This
in the
is
store.
likely a basketball 78 centimeter in front of you.
Or think about a storage warehouse worker, right? They need to find stuff.
This
You
is
just look at
likely
it.
a soccer ball 1.1 meter in front of you.
Or think about furniture assembly, right? You buy some furniture, look at it, and it will actually show the assembly steps.
This
in
is
3D.
likely an upright piano 2.1 meter in front of you.
So pretty cool stuff. Well, let's switch machines here, and I'm going to show you the Unity scene and also a bit of Visual Studio. All right, cool. So this is the Unity scene, pretty easy. We just basically have a main camera here with the status text below it, which you have seen in the video. And then most importantly, we have our DNN model here. So there's a custom script I've written, which is called DNN model behavior right there. And I'm going to show you what it does in a couple of seconds. And then we have another game object here called Spatial Mapping. So I'm just using the Spatial Mapping collider in that particular piece. As you probably know, there's also a Spatial Mapping renderer, but I'm not interested in seeing the spatial mesh of the HoloLens. What I'm really interested in is only the collision, because what I'm doing for measuring the distance, I'm shooting out a ray from the user's head, which is the main camera, and do the ray cast into the scene, and then I get where it hits probably the spatial mesh. I can just use the distance, right? That's what I'm using for the output when it tells you, oh, this is blah, 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 50 centimeter in front of you. So we're using the spatial mapping collider there. Well, and then we have the gaze cursor, like this little green cursor you have seen. Pretty straightforward, but also pay attention to the project setting here. So we have our resources folder, which is that special Unity folder where all the stuff that is in the resource folder will be shipped as part of your package workload. And there's a labels.json file in here. As you can see, it has indices, and then you have all those labels attached to it. Again, the ImageNet database, 1,000 objects. So in my output layer of my neural network, I have 1,000 neurons. So this is just using the index mapping from the output layer neuron, which it actually is, right? So when neuron, for example, neuron with the index 6 fires, I know it's actually Stingray. So I can just map that in the UI, that's all. And then we have our SqueezeNet Onyx model as part of the workload here. Okay, so let's switch gears to Visual Studio, and I'm going to show you the code behind all of that. So this is the DNN model behavior here. And as you know, the start method is called by Unity once this game object or once this component is executed the first time. And most importantly is this part here. So there's a custom class for SqueezeNet model. And there's a method I implemented called load model async. So let's jump to that. You can see there's this load model async, and there's a bit of code here to parse the JSON file, pretty straightforward. And by the way, I took most of that sample from the official Windows machine learning page, but they have a 2D UWP app. What I made is I transformed that into a 3D app using Unity, added spatial mapping, and all of that on top of it, right? So you can also find some good examples there from the Windows machine learning team. All right, so we parsed the labels, and now we actually need to load our Onyx model. And as you can see, those APIs are still in the preview mode, so they even have it in the name. And of course, I would have loved to actually use this API here, which is called load model from stream async. But this throws a not implemented exception at the moment, so we actually have to load it from a file. And we have to do a bit of a workaround to actually get it from the resource folder into a file that UWP understands. So shout out to my friend Mike Talty. He had a very good blog post out there that shows how to do exactly that, how you can get it from the resource folder into a UWP file for loading it. All right, so we loaded it. After that, we're setting a bunch of options here. For example, a preferred device kind. So I could say run on the GPU, run on the CPU. Of course, most importantly, what I really want to do is run on the GPU, but DirectX 12 driver is not available on the HoloLens, so we have to run it on the CPU, right? After that, we get some more descriptions like input image description. And here's another awesome piece I want to highlight, is that WinML already provides you the features to actually handle images. So you don't have to worry about transforming your pixels into floating point values, which you need to input into your neural network. It will already take care of that because it understands images, basically. And then we also get our output tensor description. So tensor is basically a fancy name for vector. So output vector of the values, which is 1,000 elements. Okay, so we got our model loaded here. Next piece, what we need to do is we need to initialize our camera. Another custom class I've written, Media Capturer, which uses UWP Media Capture internally. And I don't want to dive too deep into that. You can check it out later in the source code. Again, it's all available. One thing I want to highlight, though, is this piece here. So I'm calling the method I've written start capturing, and I pass in the input description. So I pass in the pixel format and the width and the height I got from the WinML model loading. So that's also pretty nice. So they actually can tell me what is the expected input size. They would actually take care of automatically downscaling it or scaling it to the right size, so you don't have to worry about it. You can just pass in whatever image you have. But in order to save some cycles and get best performance, I actually can also ask UWP Media Capture to give me the frames in the right size already, right? So that's what we're doing here. So I'm just passing in those values. All right, so if we have model loaded, we have the capturing initialized, and then we do our task run. So I run the whole processing in a background thread. I get the latest frame from the camera. I pass that into this method here, evaluate frame. This will run the evaluation on it. I check if there's a result returned. And if there's a result, I will actually have to dispatch to the UI thread, because I'm running on a background thread, right? And I want to update UI elements. Then there's a bit of string formatting here. And at the end, this is the code that does the speech synthesizes output. And I'm using a piece here from the Mixed Reality Toolkit, which is called text-to-speech. And that wraps the Windows 10 speech synthesizes APIs in such a way that you can actually use it with a Unity audio source. So that's pretty awesome. And it's really simple. You just call the start speaking method here. And as you can see, it just takes a string as an input. So you can use any string and it will just say it. So it's super straightforward. All right, that's pretty much all I wanted to show you for the demo. And again, you can get all the source code on my GitHub page. Again, at the end, there will also be a slide with all the links on it. So you can just grab a snapshot of the last one there. Cool, so let's move on. Let's spend the next 20 minutes on my top 10 HoloLens development recommendations 2018. Number 10, treat the HoloLens as a mobile device. That has not changed, because the HoloLens is a mobile device. It's awesome, it's untethered. You can just freely walk around. But of course, you cannot expect the full computing power of desktop graphics card. That's just it, right? What we noticed, it's mainly fill rate bound, which means if you're rendering objects very close to the user's eye, they take up a lot of pixels. And if you have a heavy pixel shader running on that, it will drop the performance quite a bit. Also, if you overlay objects, for example, if you're using the Unity UI system, and they have sometimes panels, and then you stack another thing on top of it, and another thing, it will render all of those again and again. So all those pixels will be rendered again and again, which is called overdrawing. And you definitely want to avoid that, because this is really expensive on the device. What you can use is, you can use some optimized shaders from the Mixed Reality Toolkit, or sometimes you can even get away with an unlit shader. So you pre-compute the shading. You pre-compute that and bake that into the texture, right? That's another good option. So keep your pixel shader very simple and don't overdraw, right? So that's really these main things you need to keep in mind, because you want to have real-time rendering performance. You can also do other things, of course, because sometimes you really have 3D models from clients that are way too big, way too many polygons, millions of polygons, right? And you cannot render those on the HoloLens. What you need to do is you need to do polygon reduction. I actually, in fact, gave a talk at the Vision VR AR Summit about some of those strategies. We also published a blog post on the Valorum blog about different strategies, so you can dive deeper into those. But in a nutshell, you can use automatic reduction. There are some good tools available. Microsoft, for example, they acquired Simplygon, so they have a pretty good tooling. And that's actually what we're using. So our 3D artist mainly uses Simplygon for doing a bit of base reduction. And then we do the fine-tuning afterwards, right? If there are, like, for example, any errors that happened or any things didn't optimize so well, so you can hand-tune them afterwards. Another option is you probably have, or maybe you have seen the talk by Unity yesterday by Oliver about the Pixies collaboration. So the Unity guys have a collaboration with Pixies, which is another really nice product you might want to check out for polygon reduction. And this video is showing you another piece called Umbra. So just look at the bridge there. So once I'm looking there, it fills in those details. So this is called dynamic level of detail. That's another product you can look into. The original model here is a 30 million polygon model. And, well, you can render that with some, of course, you see there are some things that might not look perfect, but you can at least render it on the HoloLens, and it does dynamic level of detail, right? So it fills in those pieces if you actually look at them, if you actually need to render them. If you don't want to do that, if you're not allowed to live with those little artifacts, or if you cannot actually reduce it, there's another way. You can offload it. So you can use a piece called holographic remuting. What holographic remuting does is it takes the input from the HoloLens, like your positional and rotational data, the gesture input and all of those, sends that to PC, and actually the PC is rendering the scene, right? And then it streams the rendered frames back to the HoloLens over Wi-Fi. That works pretty well, especially for static models. Let me show that video real quick here. So you can see there's a laptop in the background. That's my laptop running Unity. And in the front, well, that's what I see with the HoloLens. And you can see if I shoot this stuff there, it will actually also update there in the PC, because the PC is actually rendering the scene, right? As you can see, the latency is really not that, well, it's not a long latency. It's pretty short. And that's really boils down to having a good Wi-Fi setup. So it's definitely a good solution if you have very large models and there is no option for reducing those upfront. You can use holographic remuting. Unity 2018.2 will actually allow you to not just run it in the Unity editor, but you can actually generate an exe file from it. So you can run holographic remuting just as an exe file, as a program, right? So you don't have to run all that stuff in the editor of Unity. Design in 3D for the holographic frame. Yep, so we're still seeing quite a bit of 2D UI paradigms in the holographic applications or mixed reality applications. But the good thing is that this is changing quite a bit, and in fact, there are a lot of 3D UIs being used these days. So because we live in a 3D world, we have a device that is capable of understanding the world around us, and we want to render 3D UI in that, because this is what we're used to. So think about that. Another part, of course, think about the holographic frame. Some people call the holographic frame the field of view. It's basically the display size of the HoloLens, right? It's not full-faced. So one strategy you can use is, for example, let me show the video here real quick. So for this demo, the user is allowed to place this hologram initially. And if the user wants to place it too close, we're not allowing it. You see it turns red. So the user can only place the hologram at a certain distance. And this will make sure that this hologram fully fits into the holographic frame, right? And the tire is not being cut off at the top or the bottom. And the good thing is the user can just always walk closer, because we have an untethered device. You don't need to zoom in, just walk closer, right? So keep that in mind, design for the holographic frame, and give the user a great user experience. Let your apps live in the real world. The HoloLens supports spatial mapping, so it has an understanding of your environment. So make sure that you actually place holographic objects in the real world and avoid this so-called AR floating sticker effect, where you just put a virtual object in front of the user, right? Place them on the real-world table. Place them under the table, for example. But make them part of the real world. That's really important. You can also use things like AR markers, like image targets. So you could use an image and then span a virtual object. Or the other piece I've shown you in this video earlier, where we're using model targets. So we can use a real-world physical object and then augment it with extra information. This is truly mixed reality, right? We're augmenting real-world objects with things you would otherwise not be able to see. Let it focus and stay anchored. Yep. So there is the stabilization plane in the HoloLens. So what is the stabilization plane? The stabilization plane is a 3D plane, so it's a point and a normal. And the HoloLens runtime will make sure every virtual object, every hologram that intersects with that plane is most stable, so it doesn't jitter a lot. So what you want to have is, of course, that the holographic object the user is looking at is using this API. Good news is, with Unity 2017.4 and the HoloLens RS4 or April 2018 update, you can use a new feature which is called depth buffer sharing. So you can just go into your Unity player settings, enable depth buffer sharing, and that will basically use the depth buffer, right, and pick the closest object, and will set the stabilization plane at that object. So it makes sure the closest object is always the most stable one. Let me show you a bit to make it a bit, make the explanation a bit better here. So what you see in the big frame there is the device portal, and on the lower right, this is what I recorded with the HoloLens. So let's take a look at the video. So in the device portal, there's this 3D view where you can actually show the stabilization plane. So you can debug it in your application. So if you take a look here at this red plane, if I look at the dog, it will actually snap to the dog. So even if I move slightly, the stabilization plane will still be at that holographic object and make sure it's in the scene. Same thing here with the cat. And yep. So again, you can use the automatic depth buffer sharing or use it manually. And there's an API called focus point, so you can set the focus point manually. But please make sure to make yourself familiar with it, because I still see a lot of apps that jitter a lot. And this is typically the case when you not care about stabilization plane. Another piece I want to highlight is called the world anchor. And a world anchor is basically a piece where the HoloLens runtime assigns the coordinate system to a virtual object. So you can assign your hologram a coordinate system. And then the HoloLens will make sure that this particular piece stays at the real-world position. Even if you, for example, walk outside of the room and walk back in, it will still be relative at its real-world position. So how does it look like? You can also enable that here. Show spatial anchors. So you see those little coordinate systems, those little gizmos right next to my head there. And these are the world anchors. So there's one for the cat and one for the dog, of course. And this is a way to also debug them. Nice feature with the world anchors is you can also, well, you can reload them. So you can save them, you can persist them. Once you reload the application, you can bring them to life again, and they will be at the same position where you left them. So stabilization plane and world anchors, please use those. Share your holograms with the world. So how can you share your holograms with the world? Well, first of all, there's a Microsoft store. There's a section for mixed reality, so you can submit your applications to the store. We used it quite a bit for marketing purposes, but also to share it with our clients, because there's a new feature they just released where you can have a kind of a private mode, where only a user, so basically you would take the Microsoft account from the users you want to share the application with, then add those to this application, and only those people can actually download the app. So this is a good way for beta testing, or if you don't want to share it in public and just with some specific clients. That's one way. Another way to share your holograms, well, you can make a video, right? You have seen the mixed reality capture. That's what I have been using here. So the HoloLens has this little camera on the top, and you can use it for recording, and then we'll add the virtual objects on top of that. The mixed reality capture here, this is an example, has some downsides. First of all, it does the encoding of the video on the device. So that takes a bit of time. So it will actually cap your application to 30 frames per second. Another piece is the camera on the HoloLens. The RGB camera is not that great, so you don't have really a good camera there. And the third one is the blending is not as it is when you actually look through the HoloLens. And there are some other things you can do. For example, spectator view. So if you have seen some of the keynotes from Microsoft, they use this special camera setup where they have a HoloLens mounted on top of a really good camera, like a DSLR camera. What it does is, it actually also does the rendering on a PC. So you just use the HoloLens for the tracking, and the DSLR camera feed is both sent to the PC. The PC renders the scene and does all the composition. Good news is, Microsoft open sourced that, so you can take a look at the spectator view. It's all open source. And also some companies actually made their own version. For example, we made one which is called Mirror, which is looking like this. So you have a much better quality, of course, right? Much better camera, so we can shoot 4K, and you can see the rendering is much nicer. And this is a way how you can share your holograms with the world. Leverage the tribal knowledge. Yep, so there are awesome, smart people out there, and I actually recognize some of them all here in the audience, which are very active in the community. So we have a very good and active community for HoloLens and mixed reality in general. And you can ask those people, super nice folks, right? They can help you. And especially if you're an indie that just wants to get started, there's so much good stuff you can use from this tribal knowledge, right? So here's a quick video, just a screen cap. I made this short link, bit.ly MR expert, and it will bring you to this page, which has all the nice links. So you can go to the forums and just ask a question in the forum, or you could use the Holo Developers Slack channel. Really, really good Slack channel with an awesome amount of smart people. And we have the Mixed Reality Unity Toolkit, which is an open source project that provides you scripts, samples, shaders, and all of that to get going much faster. It's mainly driven by Microsoft, but they also take community contributions. And in fact, one of my team members, Stephen Hodgson, is one of the main contributors here. So shout out to him. Also, Unity has their own forums. Unity also has, Academy. Academy, of course. You can use the Holographic Academy and look into some of those tutorials. And yeah, Unity forums, if you're really getting started with Unity, it's also a good resource. Think outside of the box. So I've shown you HoloBeam, where we're taking a depth camera, like the Kinect, and can take the data and visualize it in the HoloLens. The HoloLens is already packed with an amazing amount of sensors, but there's even more around us, right? Here's another example where we're using the Kinect. So take a look at the top middle. You might spot the Kinect there. So what we did here, we synchronized the coordinate space of the Kinect with the one from the HoloLens. So we can use the skeletal tracking of the Kinect and stream that in real time into the HoloLens and do things like that. The delay you notice here is actually not the transfer. It's the delay that comes directly from the Kinect skeletal tracking, right? And that's just one example. There's lots of devices out there, right? Smart home devices. We heard a lot about the intelligent edge and IoT devices. And in fact, like this little guy here, right? This Azure IoT button is a Wi-Fi stack. So you can just use the HoloLens and connect with it, because it's supporting Wi-Fi. And you can do some fun things probably. So just press the button and then, well, I don't know, hologram will appear, or you can probably figure out some creative things with it. Long story short, the HoloLens is a Windows 10 device supporting UWP. You have the whole network stack. streaming sockets, all of the goodies, so you can pump in a lot of data. Make use of that. Built for the whole mixed reality platform. Yep, the HoloLens is a Windows 10 device running the Windows mixed reality platform. But it's not the only device that runs it. You probably have seen some of those immersive devices. Some people call them occluded mixed reality devices. Others just say it's virtual reality devices, right? But they run also on machines that support Windows 10 and the mixed reality platform. So you can build for the whole platform and not just for one device category. The nice thing is most APIs work, of course, because it's the same platform. And also the MRTK has a bunch of goodies in there. Here's, for example, a piece from Dong-Yong Park. He added two-handed gestures to the MRTK recently. So you can see he's using two-handed gestures with the HoloLens. And then he can use the same two-handed gestures, but with motion controllers on the immersive headset, right? So here it is with the motion controllers. What you probably want to do is if you run the application on an immersive device, you want to render virtual environment, of course, and a ground plane or something like that, because the user is not seeing the real world around them, and you want them to provide some grounding there. Yep, and most importantly, learn about deep learning, right? You cannot avoid that. That's really something you need to make yourself familiar with. So you don't have to be a researcher. You don't have to create those models from scratch, right? This is stuff that goes into scientific papers. But at least you need to be familiar with the concepts. You need to understand what is a convolutional neural network, what is an LSTM network, how do I apply that, right? You need to be familiar with those kind of concepts. Because you can take existing models already that are pre-trained. You can use custom vision to make your own object recognizing model. That's easy, but still you need to be familiar. You know, what is an output layer? What is a tensor? And how does all those things work? And how can I interpret the results? So learn a bit about it. And of course, always think about the implications of your work, right? You have a super powerful tool at your hands, right? So think about that you're doing good things with that. That's another important piece you probably have here in the keynote is about responsibility. So especially in this age now with AI, you as a developer have a huge responsibility about doing good things with it, right? Because you can do pretty bad stuff with it. So think about the ethical implications there. All right, so here are the resources. If you want to get started with AI, you can see the Microsoft AI School at the bottom there. They just opened it up to the public, so you can follow some of those. But I would highly recommend to check out Brandon Rower deep learning videos on YouTube. I just linked 2 here. And he does an amazing job explaining very complex topics like convolutional neural network in a video that is like a bit more than 20 minutes. And it does it very well visually. So check out those videos. Another one is, of course, mixed reality community, as I mentioned. And then you have a link to my blog. So I will post the slides and source code links and all of that stuff on my blog. And at the bottom right, you see my Twitter handle. So you might want to follow me there, because I will share once I push the stuff to my blog. Demo code in GitHub, a couple of other talks I did before, and that's pretty much it. Oh yeah, and related build sessions. So some of those already happened, so you might want to catch the recordings. Some of those are still today and tomorrow. Good stuff about Windows machine learning and so on, so check those out. With that, I thank you a lot for your attention, and please evaluate this session, and I wish you a pleasant rest of the Build conference. But actually, we still have 1.5 minutes. So if you have a question, please feel free to come up to the mic and ask it now. Otherwise, I will stick around for the rest of the conference. So you can find me and ask me if you want. All right, thanks a lot. Enjoy the rest of the conference.